Okay, welcome back. In this video, I'm going to go over some of the advanced integration techniques that you normally, they are very rare on the AP test, but they do appear on the AP test. So you should know them, but these might be the ones you end up skipping in the multiple choice. However, you don't want to skip too many of them, so let's go ahead and go through them. The first thing is the integration involving the inverse trig functions. Now, you're not integrating the inverse trig functions, but you're integrating a form that represents the antiderivative of these forms are these inverse trig functions. Now, obviously, there's 6 inverse trig functions, but only 3 of them appear on the test. One of these 3 will usually appear on the test, not all 3. Again, that's what usually happens. But I'm going to go over all 3 of them, and the bottom line is you need to memorize these. So if you want to put them, on note cards and start memorizing them, let's just go over the U form of it. If you have the square root of something on the bottom, and it's something squared minus some function squared. We've done these before, but when we set the U equal to our inner function, we usually had its derivative up here. Well, you're going to find that when you look at this, if we set our U equal to our inner function here, its derivative is negative 2x dx. There's no x dx up here. There's no x up here. So that's not going to work. Our basic U substitution is not going to work. Okay? So, memorize these. The square root of a squared minus u squared is the arcsine of your u value divided by your a value. If it's just a squared plus u squared on the bottom, and again, u is a function. U is a differentiable function. Then it's the arctan. It's 1 over your a value, and the arctan, or tan to the negative 1, of u divided by a. And then this one, when you have a function squared minus a number with a function out in front, that's your arcsecant. So we're going to be practicing these, and the more we do them, the more you'll recognize them. So basically, memorize. So, okay, so let's take a look at the first one. This is the square root of something squared minus x squared. That's a constant, a number minus a function squared. A number minus a function squared. Well, it's not a 1. So that is a squared minus u squared. Okay? So that's what you need to identify first. This is a squared, and this is u squared. So if a squared equals 4, then our a value is 2. And if u squared equals x squared, then our u is x, which means our du is dx. So just like before with u substitution, you always need to find the derivative of your u. So now we can rewrite the problem in terms of u. So let's start with the dx on the top, or it doesn't really matter. Start with the dx. What's dx equal to? Du, and the square root of our a squared minus our u squared. Right? So that is which one? A squared, the square root of a squared minus u squared. That's arcsine. So when you integrate this, you get the arcsine of your u value, which is x, divided by your a value, which is 2, plus c. And that's the answer. If you wanted to, you could write it as sine to the negative 1 of 2 over x plus c. But just remember, this means arc sine. It's not a power rule or anything. You can't add 1. That's just another notation for arc sine. Either one is acceptable. All right, let's look at the next one. Now again, if we set u equal to our denominator like we have in the past, its derivative would be 18x dx. Well, we don't have, the 18 is not the problem, but we don't have an x dx. We only have a dx. So the basic u substitution is not going to work. But if you look here, a squared plus u squared. So this is our a squared, and this is our u squared. So what's your a? The square root of 2, correct? And how about this one? If u squared equals 9x squared, what is u? Hopefully you said 3x. So, oops, don't forget, take the derivative of your u, just like before. We picked our u, took the derivative, now we rewrite in terms of u. So let's go ahead and start with the dx. What is dx equivalent to? Dx is equivalent to du divided by 3. du divided by 3. Let's put those coefficients out in front. Over a squared plus u squared. So that's this one right here. That's arctan. So we have to memorize this. So the 1/3 will stay as our coefficient. Okay, so the antiderivative that you have to memorize is 1 over your a value times the arctan of u, which is 3x, divided by your a value again, plus c. And that's your answer. Okay, next one. This kind of looks like this. Okay, and again, if I set this equal to my u, its derivative is 8x dx. Well, I have an x here, okay, but I don't have it up here. And that's where it needs to be if I set this equal to u. So I can't do our usual u substitution. So I need to recognize that as this here. Okay, so four x squared is u squared. Our 9 is our a squared. Oops, sorry about that. So what is u equal to? If this is u squared, So that means that du equals 2dx. And then if a squared equals 9, then a must be 3. Okay? So now we can do our u substitution. So start with the dx on the top. What is your dx equal to? It's equal to du divided by 2. du divided by 2. Again, coefficients can always go out in front. We like to do that. Move them out of the way. Okay. All right. Now this x right here. What is x equivalent to? U divided by 2. I'm just going to put that in the denominator right now. U divided by 2. I'm not going to pull that divided by 2 out just yet. I'll talk about it in a second. Okay. And then we have the square root of u squared. Minus a squared. Okay, so everything is in terms of u. But we've got this little 2 right here. How do I pull that out here? Think about that. Well, this is technically 1/2 in the denominator. If you're dividing by 1/2, that's the same as multiplying by 2. So when you pull that coefficient out in the front, you get this. So then these end up canceling, and then you can recognize this as your arc secant. And arc secant, again, I know it's new to us, but we have to memorize 1 over our a value, which is 3, times the arc secant of the absolute value of our u, which is 2x, divided by our a value, which is 3. Okay? So those are the 3 you should know. Okay? All right, we're going to be using some of these in the next problems too. All right, the next thing that you could see on the AP exam are rational functions that look like this. Okay? Well, we've already dealt with rational functions. But look at, what did we do when we had a rational function before? We set the denominator equal to u because its derivative was usually in the numerator. But that's not going to be the case because your numerator is larger than your denominator by 1 degree. So in this case, we can't use our normal u substitution that we've done in the past. And you can't set your numerator equal to u because you can't have the correction factor. You can't have the derivative in the denominator because that's not going to work. So in these cases, you have to remember your long division. So let's review long division. Okay. All right, so I'll go ahead and do the long division right over here. First of all, you have to remember that you're dividing by x squared plus 0x plus 4, because you need to have all of your terms there. And you're going into 3x cubed plus 0x squared plus 2x plus 5. Okay? All right. So now what? Well, we are dividing 3 terms into 3 terms here, but you only look at the first ones. X squared into 3x cubed. What times x squared gives you 3x cubed? You put it above the third term here because we're dividing by 3 terms. That gives us 3x. So again, compare this to this. Remember that? So now we pick or choose, and now we multiply. 3x times each one of these. Three x cubed plus 0x squared plus 12x. And then what? Subtract. 3 minus 3 is 0. 0 minus 0 is 0. 2 minus 12. That's a negative 10x. And then you bring down the 5, and you go again. Well, do we have to go again? Once this degree is smaller than this one, you're done. This is your remainder. That's your remainder. So what you just found is that the original problem, this rational function, is equivalent to 3x plus a negative 10x plus 5 all over your divisor. So by doing long division, you have just rewritten this rational exponent into these two pieces. This is equivalent to this. Okay? So what we're going to do is we're going to integrate both of these. And sometimes, and you don't have to do it this way, sometimes it's easier if you split them up with the integral sign, but that's completely up to you. Okay? So this one we can do easily, but let's focus on this one for right now. We have a binomial and a binomial here. Okay? If we set our denominator equal to u, its derivative is not going to have a plus in it. So this one needs to get split up even more. This is a common denominator, so I'm going to split it up even more. 3x dx plus the integral of negative 10x over the common denominator x squared plus 4 plus the integral of 5 over x squared plus 4. So I'm just breaking it down more and more and more to get it to the point that I can actually integrate. So again, this is a common denominator for this one. This is a common denominator for this term. So I split them up into 3 individual integrals. You don't need the integral 3 times, but I just like to do it because basically I'm just going to work on one problem at a time. But that's completely up to you. Okay, so now that we've broken it down, now we can actually integrate them. Okay, so let's start with the first one. So what color do I want to go with here? How about some orange? Let's start with this one. Integrate this. Add to the exponent, divide by your new exponent. Okay? I'm going to do the plus c. We'll worry about that at the very end. Now let's work on this one. What do you think? Is that a u substitution one? U equals x squared plus 4 du equals 2x dx. Okay, so I'm actually going to rewrite this as I'm going to pull that negative 10 out in front. I'm actually going to do u substitution now. Okay. I pulled the negative 10 out in front. I'm going to do what is x dx? I've already gotten rid of this. I need to substitute x dx. Here it is, right here. X dx is du divided by 2. du divided by 2. Okay. And then x squared plus 4 is our u. I'll work on this one after. Now you can see why I did an integral sign for each one, because there are like 3 problems, 3 individual problems that I'm going to be working on. So I finished this one. I'm working on this one right now, which is, what's the derivative of this? The natural log of the absolute value of our u plus c. Again, we'll worry about the plus c at the end. So I'm done with that one, and now I have to work on this one. Think about how we might do this one. Hopefully you recognize this as u squared plus a squared. Pull that 5 out in front again. U squared plus a squared. So that means that our u is equal to x. So that means du equals dx. Okay? So I kind of did it in my head. The more you do, the more you can do in your head. I did u substitution. If you need to write more down to get to u substitution, then go ahead and write more down. Okay, now I have it in the form that I can integrate. So this I already integrated. This one I already integrated. And now I have to do the last one. What does that go with? That's inverse tan, arctan. So again, we have to memorize that arctan is 1 over our a value times the arctan of our u, which in this case was x, and our a value, which is 2. Now we have a plus c, doing them individually, a plus c and a plus c and a plus c. So don't forget your plus c. And that's your final answer. So that was a lot of practice. That's a lot of different problems in one problem. All right? Let's try another one. So if you want to pause the video and practice your long division, we need to do long division because the numerator is smaller than the denominator, the degree. So go ahead and stop the video and practice your long division. Okay, welcome back. Hopefully you paused your video. If you did your long division correctly, you should have gotten x plus 3 plus the remainder is 3x plus 4 divided by your divisor of x squared plus 5. I'm not going to show you all the long division. If you need help with long division, then you can get together with me during student support time. But long division will produce this. Okay? Or you can watch Khan Academy video too if you forgot. Okay, so again, we have 3 integrals, and I like to split them all up. Again, it's just personal preference because I've got 3 different problems I have to do. So I'm going to integrate x, and again, this dx goes with each one of them, and I need a dx in order to integrate. So I have 3 dx, and I have 3x plus 4 over x squared plus 5 dx. So I have 3 problems here. But again, look at this. This is just like the first one we had. A binomial divided by a binomial. Okay, that's not going to be your basic U substitution. We have to keep breaking this down. So we have x dx plus 3 dx plus the first term 3x divided by the common denominator plus the second term divided by the common denominator. Now I'm ready to integrate. Four problems, basically. So let's start with the easy one. Integrate x. You add 1 and divide by your new exponent. You add 1 to the x. Well, there aren't any x's. So it's x to the first and divide by your new exponent of 1. So those are the easy ones. How about this one right here? That one to me looks like U substitution. So U, and some of you won't have to write this down after a while. You'll be able to do it in your head. If U equals x squared plus 5, then du equals 2x dx. So I'm integrating. I'm going to pull that 3 out in front. This is all a continuation. I probably should move that down, but this is all. This is already done. I'm working on this one. So I'm going to pull the 3 out in front. Okay. So now x dx. What is x dx? It's du divided by 2. So I took care of the 3. I took care of the x dx. Now x squared plus 5. That's my u. Okay. So I still have to do the last 2 here. All right. So this is done. This one is done. And now this is ready to be done. The natural log of the absolute value of your u. Now you actually don't need absolute value on this one. You can use parentheses because x squared plus 5 is always positive. Okay? And now we're left with the last one. What do you think? I think that it's 1 over u squared plus a squared. That's what I think. And since u is equal to x, then du is equal to dx. So again, I kind of did that in my head. If that was too much for you, you could write it off to the side and do your u substitution. So what is this? U squared plus a squared. Yep, that's arctan. So 1/2 x squared plus 3x squared plus 3/2 natural log of x squared plus 5 plus, all right, so 4, what do you have to memorize for this one? 1 over your a value times the arctan of your u, which happens to be x, divided by your a value. And then your plus c. And you're finally done with that problem. Okay? So long division to make it look different so you can make it look like one of our rules. All right. We're about halfway done here, so if you want to take a break and come back to the video, you can do that. Look at the time on the video. We've got a couple other ones to go over. Oh, here we go. Let's talk about completing the square, another one of your favorites. Completing the square, to make this a perfect square trinomial, you take half of your b value and you square it. The reason why you complete the square is so you can factor it into a square binomial. Because when you complete the square, you're making this a perfect square trinomial, which is equivalent to the square binomial. So that's a little review from 10th grade as well. So let's look at this problem and why we would need to use completing the square. Well, again, let's go back to the very first day with u substitution. If I call this u, its derivative would be 2x minus 4 dx. There's nothing here. So that can't be my u. I can't do long division. I can't integrate the way it is. So let's try completing the square and see what happens. So I know this is not a perfect square trinomial because of that 7. So I want x squared minus 4x plus something, and yes, it's always a plus something, to be a perfect square trinomial. And I'm just going to move the plus 7 out of the way. But as you know, I can't add something without undoing it. Otherwise, I'm changing the value. So I'm just trying to change the looks. Remember that? All right, let's fill in the blank. Half of your b value squared. That's 2 squared, which is 4. So I'm going to add 4, and I'm going to take 4 away. Well, why do I want to add and take away? Again, I'm just trying to change the looks. The reason why you complete the square is these first 3 terms here is a perfect square trinomial, which factors into a square binomial. So let's review how to get the binomial. The first term, the square root of the first term goes here. This first sign, this is always going to be a plus. So this could be a minus, this could be a plus right here. So if this is a minus, that's a minus. And to get the second term of the binomial, you can do one of 2 things. Square root of the C value or half of the B value. Either way, you'll get a 2. And then you still have 7 minus 4, which is 3. So did that help us at all? Does that look familiar, or does that look like a form that we've been talking about? I hope it does. This is u squared, and this is a squared. So that means u is equal to x minus 2. So du equals dx. And this means that a is equal to the square root of 3. So let's go ahead and rewrite it now in terms of u, and let's see if we can get the answer after that. No, that wasn't very good. Let's try that again. The integral dx is du divided by u squared plus the square root of 3 squared. What is that? That is arctan again. Arctan. So, your answer. What do you have to memorize for this? 1 over your a value times the arctan of your u divided by your a plus c. And there's your answer. Okay, no need to rationalize denominators on the test. All right, let's try another one, completing the square. Okay, so again, if we go with the first thought is, oh, I'm going to make this inner function my u. Well, I have 1 over the square root of u. Its derivative of u is negative 2x, or it's actually 3 minus 2x dx. That's not in here. So I can't use our normal, just basic u substitution. Okay? That doesn't work. Long division isn't working. So we're going to have to do completing the square. So what I want to do right now is I just want to pull out, I just want to work on this right now, just by itself. Let's just work on that. That is equivalent to a negative x squared plus 3x. I'm going to put it in descending order. So something that you should remember about completing the square is that you cannot complete the square unless there's a 1 in front of the x squared. So I pulled out a negative, and I'm going to work on the inside here. X squared minus 3x plus something minus something. I need to get this trinomial to be a perfect square trinomial. So again, half of 3 squared without a calculator. Half of 3 is 3 over 2. You square 3 over 2, and you get 9 over 4. Now, this is the one you have to be careful on. People say, well, you added 9 over 4. I actually didn't add 9 over 4. I added 9 over 4 times a negative 1. Okay, so when you go to fill in the blank over here, you need to subtract a negative 9/4 to keep it equal. Because think about it, this is a negative 9/4. I need to undo it with a positive 9/4. So it's equivalent to the original problem. I'm changing the looks without changing the value. Remember that? So that gives me a negative, this is my PST, so that's x minus 3 over 2, the quantity squared, plus 9/4. So that's just the review of completing the square. Now that we've completed the square on this, let's rewrite the problem. Okay. 1 over the square root of all of this. All of this is equivalent to all of this. Now, I don't like to ever write a negative first, so I'm going to write my positive 9/4 first. And then I'm going to subtract x minus 3/2 squared dx. What do you think? Recognize anything? Well, you should recognize that this is the square root of a squared minus u squared. And if you don't have those memorized, then you're not going to recognize that. So this is our a squared, and this function here is our u, because this whole thing is our u squared. So u is equal to all of this. U is equal to x minus 3/2. So du is equal to dx. Over here, this is our x squared. I'm sorry, this is our a squared. So our a is equal to the square root of that. So if we rewrite it in terms of u, we have the square root of a squared minus u squared. And then what's our dx? Just so happens to be just du. All right. So now do you recognize that? The square root of a squared minus u squared. Which trig function is that when you integrate? It's back on your paper. It's right here, arc sine. So it's the arc sine of your u, x minus 3/2 divided by your a, divided by 3/2, I don't like that, plus c. I don't want to divide by 3/2. I want to multiply by its reciprocal. So I'm going to change this to arc sine. I just like that notation better. It's personal preference. So I have 2/3 times x minus 3/2 plus c. So instead of dividing all of this by 3/2, I'm going to multiply all of this by 2/3. Okay? So what do you get? You distribute, you get 2x over 3 I feel like I made a mistake. Oh, that's right. Or, again, it's multiple choice. That's the same thing as 2x minus 3 all over 3. Those are all the same. Okay? Make your answer look like one of theirs. All right, so that's completing the square. All right. Last technique. This one's pretty cool. Again, it's rare that you see it, but I have seen it. So I want to show it to you. So if you think about this one, we have a rational function here, and we're like, oh, okay, I'm going to set my denominator equal to my u, because that's what I always do. But when I set this equal to u, and again, I always say it, if you need to write it down, write it down. du equals e to the x dx. Well, if this is my u, do I have an e to the x dx in here? I don't. So this is not going to work. Okay? I need an e to the x in my exponent in order to do that. So why don't we make an e to the x in the numerator? How do we do that? Well, easy. You have a 1 there. Let's add an e to the x in the numerator. But as we know, we can't just add it without subtracting it. Okay? So this, if I take these undo each other, that's equal to that. Now, why would I want to do that? Well, if I take this as a term and I take this as a term, I can now split it up into two integrals. I can take 1 plus e to the x divided by the common denominator, and I can subtract the second term here, e to the x divided by my common denominator. And again, when I'm doing problems, I like to split it up into separate integrals because I'm going to be doing them one at a time. You can have just one integral if you have all of this in parentheses. Again, it's just personal preference. So I'm going to work on this one right here. Notice anything? 1 plus e to the x over e to the x plus 1. I'm asking you to integrate 1. That's what I'm asking you to integrate. And on this one, now I can use this up here. Can't I? I'm asking you to integrate u equals e to the x plus 1. So what is e to the x dx? du. So I couldn't use this here, but by doing this little trick, I now have the e to the x that I want. So integrate 1 with respect to x. Another reason why I like to split them up, because this one is with respect to x, and this one now is with respect to u. So I can treat them as separate problems. So add and divide, or the integral of 1 is x. And then what's this one? The natural log of the absolute value of u. And our u was e to the x plus 1. And don't forget your plus c. Okay? So if you don't have it, if you don't have what you want, make it what you want. All right, last one. So we're like, oh, okay, this is x squared. My denominator is larger than my numerator, so let's go ahead and let's pick our denominator to be u, because that's how we've always done it in the past. So what's du? Du is 2x minus 2 dx. Uh-oh. I have a 2x minus 1 dx. I need it to be a 2x minus 2 dx. Well, let's make it 2x minus 2. Mm-hmm. 2x minus 1 is what I have. I want it to be minus 2. That means I need to subtract another 1 from the top, which means I then need to add a 1 on the top. So why would I do that? Because then I can treat the 2x minus 2, I can treat this right here as my first term. And I can split it up like I did previously. So I would get 2x minus 2 over x squared. I'm going to run out of room, so I'm going to go to the next line. I can take my 2x minus 2 divided by my common denominator of x squared minus 2x plus 3 as my first problem. And then I can do 1 over x squared minus 2x plus 3 as the second piece. Common denominator, just splitting them up. All right, so this one we already started, right? This is 1 over u. And what is 2x minus 2 dx? du. That one we already started. How about this one? That looks like a completing the square problem. Oh no. X squared minus 2x plus something plus 3 minus something. Half of b squared. Half of 1 squared is 1. Okay. Well, I can actually do this one now. And then I'll finish this. So let's do this. What's the integral of this? That's the natural log of the absolute value of our u, which was x squared minus 2x plus 3. Plus, I still have to do this piece. 1 over x minus 1 squared plus 2 dx. Recognize that? U equals x minus 1. A equals the square root of 2. du equals dx. So when du equals dx, you can just go ahead and integrate this. You don't have to change it to u's. Again, the more you do, you should be able to do that in your head now. So if you need to write this in terms of u to integrate, go right ahead. But because du equals dx, it's pretty much a straight conversion. So this we already did. What is u squared plus a squared? Which trig function was that? Inverse tan. So what do you have to memorize? 1 over your a value times the arctan of your u divided by your a value plus c. Final answer. Okay, wasn't that fun? So again, these do appear on the AP test, but they are definitely more advanced. So I wanted you to be able to at least be exposed to them. Hopefully you can figure them out when you get to the test. If not, these are the ones that you skip. And that is it.